Okay, good evening, everyone. Good morning, good afternoon, wherever you are. Welcome to the second part of Measure Phase. Um, this session would last probably less than an hour, but I would expect you to do the exercise right after the training. So just a recap, we are now in the Measure Phase. We have covered define, and in Measure Phase, we have covered the first part last week, where we had an overview of statistics. And last week, we also covered two types of data, and then the measures of central tendency and variation. For this part, we are going to discuss the graphical tools that are used for yellow belt, and primarily we'll be covering tools like Pareto, Histogram, box plot, and scatter plot. So as a recap, in the descriptive statistics part, there are two sections to cover. One is the graphical presentation, which will be the coverage of this module, and the other one was numerical measures, which we covered last week. Okay, in the numerical measures, we went through the definitions of location, the mean, the median, the mode, and the quartiles. And we also looked at measures of dispersion, range, standard deviation, variance, which is just the square of the standard deviation, and the interquartile range. I'm not sure if I mentioned this, but interquartile range is just the difference between Q3 and Q1, okay? Quartile 3 and quartile 1. And anyway, we will touch that when we go to one of the graphical tools, which is the box plot. So now, the focus of part 2 is actually just the graphical presentation. As a yellow belter, if you get to be certified as a yellow belter, you are expected to be familiar with this different type of charts and to know which chart to use in whatever situation that you will be exposed to. Okay, so as I'm going through the discussion, you can refer to the slides I posted in the Facebook group. You will be referring to this templates. I do not expect you to do it during the session, but maybe after you can do it on your own to simulate whatever I will be flashing. The only challenge that I have, I think for Zoom, you have to, I think, close a window and open again if you have a different application. So this might be a bit cumbersome. There will be times when I will pause the PowerPoint and share again Excel. But let's see how we get along. Okay, so these are the 5 graphical tools that we will be discussing today. Histogram, Pareto chart, box plot, scatter plot, and run chart. And we'll be doing exercise only on 4, histogram, Pareto chart, box plot, and scatter plot. There will be no exercise for run chart, but still a template will be given to you in the event that in the future, if you would have types of data that could use a run chart, then you can use the template that was provided. Okay. This slide shows the platforms that are used when you're using Six Sigma. So actually, in higher belts of Six Sigma, like green belt and black belt, the platform that is used is Minitab. But this one is really quite easy to use. It's really designed for Six Sigma practitioners. The downside of this tool, it's very costly. Like it costs about 1,000 euros a year to subscribe to this tool. So in fact, I discourage companies to buy Minitab unless they have really data that would be they would always use for analysis. Otherwise, it's not a good investment. So the platform that we are going to use, or the software that we're going to use in this case, is Excel, which could be a bit cumbersome because you need to do some manual copying, pasting, and I had to download some available templates in Google. But the good thing is Excel is affordable. Yes, so someone asked 1,000 euros per year. Yes, unfortunately, that's the cost of Minitab. It's 1,000 euros per year or 60,000. I think they have a free version for 30 days, but after that, you need to pay. And that's why I'm trying to design a module for Greenbelt, because I have a client that would be requesting for a module in Greenbelt. I'm trying to tweak the slides because I intend not to use Minitab for the discussion. Okay, let's continue on. Okay, we now go to the first tool, which is the histogram. The histogram is just a vertical bar chart that displays the distribution of the set of data. You might have been familiar with this already in the first session that we have, because I gave an example of the chewing gum. And when we plotted the weights of the chewing gum, it simulated the bar chart that would be used to reflect the distribution of the data. Okay, so a histogram handles more on continuous data. Okay, so do remember that. And it is a snapshot. So against the run chart, run chart is more of the data across time, whereas histogram is used more of a snapshot, okay, a distribution of data in a period, in a given period. Okay. What's the use of histogram? Again, please remember that we use histogram if you only have continuous data. If you don't have continuous data, then you can't use histogram. Okay. Histogram can be used to identify extreme values. Okay, like in this case, if there's an extreme value, chances are it's an outlier. There might be a special reason or a special cause why you have this outlier, and you may want to investigate if you get to have data like this. If you have a histogram with double peaks, which means that there are two possible frequently occurring values, it might be that there are two processes involved, okay? Two distinct processes, and you might want to investigate further in identifying what is the cause where you have two peaks. Another possible scenario could be a truncation, which means it starts early. Okay, if this could be a problem, there might be a problem in your measurement system if such is the case, or there might be some underlying cause as well. And then there could be a situation where there is a gap. Now, this could be also anomalous, okay, which might require you to also investigate. But ideally, if you have lots of data, and there's nothing wrong with your process, then the histogram should somewhat mimic what the shape of a normal distribution is. Okay, so a process that is consistent, that is stable, would have a histogram that is peaked in the middle and tapers off on both ends. Okay, so I gave you a template on histogram. So I'm just gonna show you how to use it. I think there's a, yes, so this is the example that was given. There's an average travel time from station A to station B is shown attached. Okay, I think this is in, let's say in, maybe for the sake of discussions, probably in minutes. So we have to create a histogram from the data, and we would have to look at the data dispersion, how this data is distributed for the travel time of the train. Okay, so how do I do this? I'm gonna stop sharing now. Okay. Oops. Okay, hold on. I cannot minimize though. Let me see. I'll share again. I'll share now an Excel file. Histogram. Okay, are you able to see my screen? Can you see my screen? I'm sharing an Excel file.
Yes.
Okay. So this was done already. There's one files I failed to mention. There's a file called data exercise there. Okay. If you are going to get the data on histogram and cut and paste it here, the chart would look something like this. Okay. So this template gives you the values of the mean, okay, which means that the average time is almost equal to 49 minutes. Okay. The median here is 50. Okay. So how do we interpret the median? The median is just like where the middle value lies. So the median is 50 minutes. So the way that the histogram here looks like, it appears that the process is stable because your data is somewhat equally distributed. Okay. So you can use this template in the future for your future projects if you have a continuous data and you'd like to show how your data is distributed. Okay. The only disadvantage of this template is that the number of bins or the number of blocks here is fixed, is 11. I used to find before I used to find a template where the bins can be adjusted, but I couldn't encounter it again. So in the event that you encounter a template of a histogram where you can update the number of bins, that's much better because you can test how the distribution would look like. Normally, as a rule of thumb, the number of bins should be like the square root of the number of data. So if you have 100 data points, then at least the number of bins that you have should have about 10 in distribution. Okay, so we only cover histogram more as a graphical display. We will not go into the calculations because the calculations is more for the higher belts. Okay, so you just use this as a reference when you want to look if your data is stable or not. Okay, I'll stop that now. And then again, I'll share the PowerPoint. Okay. I'm not sure if there's an easier way to shift from PowerPoint to Excel. So that was the histogram. Okay. The next tool that we're going to discuss is the Pareto chart. Okay. Or a Pareto diagram. So it's a series of bars where the height reflects the frequency. Again, the height shows the frequency. But the bars are arranged in descending order, okay, from left to right. And on the x-axis are the categories. Okay, so here you are using this tool to identify which are the vital few. Okay, the vital few causes that you want to investigate. So an example of the use of the Pareto chart is it gives you that 80% of what's causing the variability in your process can actually come only from 20% of the factors. And this tool helps you more to focus on which areas or causes you would like to prioritize. Okay. This is how a Pareto chart would look like. Okay, it arranges in this example, let's say you're trying to investigate the customer complaints that's coming into your process. And this template that's given to you will arrange the causes, okay, and help you identify where to focus. So in this case, in this example, the way you would interpret Pareto chart is that by focusing only on 1, 2, 3, 4, or parking difficult, sales representative, poor lighting, and layout confusing, that's just 4 categories. So you will be already addressing 80% of the problem. Okay, so it helps you prioritize when you want. So let's say if this project is about reducing customer complaints, the Pareto chart will help you prioritize where you'd like to focus first. Okay? And later on, we'll use an example on how to operate the Pareto chart. Okay, so the Pareto chart again would look something like this, but it is a rule of thumb that can be applied in daily life. So here are some rule of thumb examples of Pareto in daily life. Okay, 20% of your clothes are worn 80% of the time. That's more. I think that's probably realistic. If you look at your wardrobe, chances are only 20% of your clothes are worn 80% of the time, more or less. Or 20% of the words that are spoken, 20% of the words are spoken 80% of the time. And this can be useful for language learning. Okay? You don't need to study all the available vocabulary. By focusing only on 20% of this vocabulary, then you might be quite fluent already. Only 20% of these words are spoken 80% of the time. Okay, so my advice, if you're learning a new language, try to look for the most frequently used words and study those first, because that could really speed up your learning process. Okay, this is one of the examples I would use. 80% of the shots are made by 20% of the players. A good analogy for this one, you can call this the Stephen Curry rule. So imagine you're playing a game against the Golden State Warriors. There are 5 in the team, and then Stephen Curry is one member of the 5-man team. And you look at the score, and that score could be like 80% of the score is coming only from one guy, which is Stephen Curry, which is 20% of the team. So how do you deal with that when you know this this information? Then you will have to guard Stephen Curry. Okay, by addressing only Stephen Curry, by addressing only 20% of the competition, you are already addressing 80% of the effect. Okay, that's how you would use Pareto principle. Another one, 20% of the files are used 80% of the time. So I think this is a good rule of thumb when you're doing your filing of your files. Chances are only 20% of your file are frequently used like 80% of the time. So in this case, the way that you could probably manage is for this these vital few files, you can immediately put it in your immediate access point, okay, so that it will be easy for you to access this. So identify what are these 20% of the files that you use 80% of the time. And the last one, this can be typical for a business. 80% of your revenues come from 20% of your customers. Okay, so that might help you prioritize which customers you would like to focus. Okay, in terms of you know, if your business. Okay, there's a question. How do you make it efficient for files? Do you put them in the desktop shortcut? Yes, we had a question here. How to make it efficient for files? So it depends, but if you know the concept that look at the files. In my case, I think 20% of the files in my computer are used 80% of the time. So normally I put them in with a shortcut. Okay, those that I often use, I put them in the shortcut. And one way to check, okay, so there's a question. I spend a lot of time opening folders and subfolders. Yes, definitely. That's a motion type of waste. You're opening lots of folders. So the technique there is to have a shortcut in your folders. And a good rule of thumb is you can use the 10-second or 20-second rule. At any time, you should be able to retrieve a file within 20 seconds. Okay, so imagine you have all these files in your computer and you randomly select a file. Okay, or if your client will say, oh, I want this file, you should be able to retrieve that file within 20 seconds or even 10 seconds. If you are able to do that, then it means that you have a good filing system. If not, then you need to review your filing system. Okay. So let's have an example of the, what do you call this, of the Pareto chart. By the way, when I stop the sharing, your faces appear on the screen, so you might want to remove the video first so that it doesn't get recorded, unless you'd like to be recorded. This is the challenge that I have, because I have to, or maybe I'll pause the recording. Oops. Oh no, it's the sharing that was paused. Hold on. Okay. I cannot minimize, so I'll just hurry and I'm gonna open now the Pareto chart. Okay. Okay, so are you able to see my screen? I'm now flashing an Excel file.
Yep.
Okay. So in this case, we are trying to prioritize the complaints in the medical setting. You will have access anyway with the slides. The only thing that I did here was to sort it from highest to lowest. So please take note that for this template, the disadvantage of, or what's cumbersome about this template is you need to sort it first from highest to lowest. I have seen a Pareto template where the sorting, even though it's not sorted, the system is able to rearrange it, but I couldn't find the template now, so I had to just use this template. Okay. So when you use this template, please remember to sort first from highest to lowest. Okay. So let's say you did that. In this case, how do you interpret this data? Okay. So the system will arrange it from most frequently to least frequently using. You can interpret it as such by focusing on the top three. So the top three in this case is rude medical personnel, slow response, and long queue time. So this is the top three. By focusing only on the top three, you will already be addressing 60% of the problem. Okay. So focusing only on three causes will already help you address 60% of the problem. By focusing on four, okay, how many percent of the problem will be addressed by focusing on four? Can you write on the chat box? Okay, by focusing on the four, yes, correct. By focusing on the four, you will already be addressing 72% of the problem. Okay, very good. Okay, so it's that simple, the Pareto chart. Okay, let me just end that again and share PowerPoint. Okay, so that's the answer to this exercise. Okay, in the yellow belt certification exam, you would expect one question to be about the use of Pareto diagram. Okay, okay, let's continue. Okay, the next tool is what you call box plot. It's a graphical display of the descriptive statistics based on the percentile and the quartile. We have covered the median, the interquartile range, okay, in the previous discussion. So it gives you an idea of comparing several groups. Okay, it's very visual. So how would you interpret this one? For me, it looks like a barbecue. Okay, there's a stick. There's like you have the hot dog here, and there's a line across the hot dog. Okay, so how do you interpret this one? The tail end, the highest is where the maximum value lies, and the first part of this hot dog is where what's called the 75th percentile or quartile 3, and then the median is that line over there, and then the beginning part of the box where you would consider the hot dog is quartile 1, and then the minimum value is the tail end of the stick. So it gives you a visual representation of how scattered your data is, and then you can compare different groups. Okay, example. Okay, so this is probably how an example of a box plot would look like. So in this example, there are 6 groups that are being compared. So I'm not sure what the data. So assume, let's say that this one is a turnaround time, or the number of time it takes a group to, let's say, process a customer, say, information. Sample 2, if you look at sample 2, in this case, sample 2 is the fastest because they're able to resolve the median. Okay, the median is like 20 minutes. So it's taking them, median, or 50% of them is 20 minutes. The most scattered here would probably be is sample 4. Okay, scattered in terms, because this one is quartile 1 and this one is quartile 3, so there's a big difference. Okay, like the quartile 1, it takes them about probably 50 minutes, but quartile 3, they take them about 120 minutes. So this one is a bit scattered, okay, or not consistent. I think the most consistent probably would be maybe sample 3, because they're quite close. Although this one, the stick is quite long, and this one are probably outliers. This might let you investigate. There might be some anomalies where there's a data that's lying outside what you would expect as the pattern. Okay, so in this case, if let's say the shorter the time, the better. Aside from team 2, which one is the next best team in this scenario of box plot? Which one is the next best team? If you can put in the chat box. If the lower the cycle time is, the better. Which do you think is the next best team after team 2? It is, yes, it is team 6. And the reason for that is the median value of 6 is, it's here, it's 44 minutes. Okay, which means that 50% of the transactions done by team 6 would fall within 44 minutes or lower. Okay, that's how you would interpret. Does team 5 have outliers? Yes or no? Can you answer in the chat box? Okay, team 5. Yes. So team 5 has outliers because there's this, which means that this probably is an anomalous data. Okay, this probably about 10. And there's another outlier here. It's probably 140 minutes. Okay. So box plot you use for comparison across groups, and you need continuous data as well. Okay, so it's very highly visual. It gives you an idea of how the data is distributed. I leave to you to do the exercise here, okay, and then you can just post a screenshot of your answers, or maybe I'll send a link where you can upload it. I want you to do it. You just need to cut and paste, and then put it in the template that was provided for box plot. Okay. Okay, next one is scatter plot. Scatter plot is used if you want to show relationship between two variables. Okay, if there's an inherent linear relationship. Okay, it can give you some correlation in the degree of the correlation. If it's a 1, then there is a strong correlation between the two. Okay. We will not go into the computation for this one. What's covered in yellow belt is more on the visual, or how it would appear. So here are some possible relationships of data that you might have. Okay. It could be a direct linear. So if it's a direct linear, it means that the higher the x is, the higher the y as well. Okay. So there's a direct linear relationship. Okay. It could be that when you plot the graph, it could be like what we call inverse linear, which means the higher, in this case, the higher the x, the lower the y. Okay. It could be a direct curvilinear, that the higher the x, the higher the y, but towards the end, the increase is much faster. Okay. In D, this one is an inverse curvilinear, and example E is a linear relationship but more scattering, or it could be that there is no relationship within your data. In higher belts, like green belt or black belt, there is a computation whether the relationship is significant. But for yellow belt, only a visual would suffice for this level. Okay, here are some examples of a scatter plot. Here, there is somewhat a direct linear relationship between income and years of experience. So how do we interpret this? So it means that the higher the years of experience, the higher is the income expected. So the higher your years of experience, the higher is your income expected. By the way, please remember that when you plot if you get to encounter this kind of data, please remember to plot the independent variable here on the x-axis or the horizontal line, and your dependent variable in the vertical axis or the y-axis. Okay. The second chart is an indirect inverse linear relationship, car price depending on age. So unless it's vintage, right? But the car, the older the car, the resale value of the car goes down. Okay, so the higher the years, the lower is the value of the car. Okay, so these are example of scatter plot. Okay, please do remember that in it doesn't necessarily mean that if there's correlation that implies causation. Okay, so for example, this is a scatter plot of number of ice cream sold versus murder rate. So it appears in this chart that the higher the murder rate is, the higher is the number of ice cream sold. Okay, so does it mean that the number of murder increases the number of ice cream that is sold? Okay, that's this chart. Okay, so sometimes when you have a correlation like this, it could be that it might be that there's one factor that's actually causing both. Okay, so it might be that it's due to the sun. Okay, if probably the sun, but this one I think it was sunburn rate, but it might be that the murder rate as well, because people get out and therefore more opportunities for crime to occur. And then when the sun is out, the sun is hot, people go out, there is high ice cream sales. Okay, so always remember when you're dealing with data, it doesn't always follow that correlation will imply causation, because there might be an underlying reason that's probably causing the two factors. So this is an example of that one. Okay. So in the template I provided you in the scatter plot, you just need to post the values here and here, and then the chart will automatically establish that relationship. Okay. So in this case, the diagonal line is moving upper right, which means that there is a direct linear relationship. Okay, which means that the time in this case, that the x-axis here is the time with the doctor. Okay, so the time with the doctor will impact on the satisfaction rating. Okay, so the satisfaction rating increases when you have a longer time that's spent. Okay. By the way, I mentioned earlier that scatter plot is used for continuous data. You can also use this actually for discrete. Okay, it could be discrete, because as long as it's numerical, then you can establish a relationship. But this is most powerful actually when you have continuous data. Okay. There is an exercise here. I leave that to you to do. So all you need to do is just copy this and put that into the template, and then you can see the relationship. Okay, and now we're down to the last graphical tool, which is the run chart. So the run chart is basically used to study whether your process is stable or not. Okay, so a normal process will be like there is random motion of your data, but it doesn't exceed what is the expected limit. Okay, I'll probably share just the template so you will have an idea. There's also a run chart template. I'm gonna stop sharing this one. And I'm gonna share again the Excel file. Okay. Are you able to see my screen? There's an Excel file here.
Yep.
Okay. So chances are 90% of the time you might not be using this for yellow belt level. But if you do, maybe in the future, let's say you're probably dealing with data with maybe turnaround time or duration and want to plot it, then you can use this run chart. Run chart is a visual tool that can give you an idea if there's anomaly in your process. So, for example, if your chart is like this, it means to say here that your process is a bit stable because it's within the limits. But let's see if let's say I manipulated one of the values here. Yeah, I think in this one, this is the average thickness of a production. Let's say there's this one shift wherein there was a problem in the machine. Okay, let's say it produced a 60 millimeter. It's supposed to be, yeah, there you go. This now tells you that there's an anomaly because there is a data point that fell out of the limit. Okay, so the run chart or the control chart, they also call it the control chart, is a visual tool that you use to spot if there are any anomalies for your process across time. Okay, so that's it. I will not cover this in detail because for yellow belt, it's you rarely get to encounter this type of problem, unless of course you have existing data that you do to process this. Okay, and then let's go back to the PowerPoint. Share screen. So that's the run chart. As I've told you, I tried to really minimize the mathematical part for yellow belt because the expectation for yellow belt is you just have an overview of your process from a visual standpoint. So just to put into context, for example, I'm showing here what's the expectation for you based on the certification level in terms of the usage of the tools. So for a histogram, as a yellow belter, if you're able to present a histogram and identify possible anomalies, you're already good. Okay. In green belt, this one is really where the math really starts to be serious. So in the event that you'd like, in the future to get certified for higher belts, as a green belt, there is a computation whether you would have to look at your data, whether your data is normally distributed or not. And there is a test, there's a statistical test for that. For box plot, the expectation for a yellow belt is you just need to visualize it and identify initial assessment of possible anomalies. In green belt, this is where you now do the statistical test, whether the difference that you are seeing are significant. And there is reason to believe that the difference you are seeing is really caused by a factor. So in green belt, there are lots and lots of statistical tests. Scatter plot, as a yellow belt, if you're able to visualize possible relationship, you're good already. In green belt, the expectation is much higher. There's some computation aspect. Using this computation, you are able to determine whether the correlation you observe is significant or not. Okay. In run chart or the control chart, which is the last tool that we've seen, the expectation is you're only able to visualize possible anomalies. Okay. In green belt, there are several tests to detect if there are any changes in the process or trends. Okay. So this is just a flavor of what to expect in the future should you decide to go for higher belts. And I'd like to acknowledge actually the following sites. This is where I got the templates that are available. Maybe my challenge to probably Jonas, because Jonas is quite good in Excel, You might want to tweak the, which one was it? Probably the Pareto chart. Okay, if you can use your power, you can actually tweak the Pareto chart wherein it can automatically sort. So the person who can input different sort, and then yeah. So that's a good thing that you can possibly do. Okay, so before we end this session, let's have a quick test. I'm going to show you some examples and which graphical tool here will be most useful in each of this scenario. So the first one, Pam is drafting a training course to help address recent audit findings, and she wants to know the top most frequently recurring themes. Which tool do you think would be most useful here? Can you write in the chat box? So top most frequently recurring themes. So themes, this is categorical, and therefore the answer is Pareto. Yes, correct. So number one is Pareto chart. Number two, Jonas wants to determine if the average monthly usage rates of farms in northern part of Thailand vary significantly versus the southern part. Okay, so it's monthly utility usage. It's a continuous data. You're comparing two things. Yes, it's the box plot. Number two is box plot. So Karen wants to know the average turnaround time for room housekeeping for the month of May. So let's say she has lots of data, she has different rooms, and each room would have a turnaround time for housekeeping. What do you think will be a good tool for her? She wants to look at the turnaround time. Yes, correct, twins. It's histogram. So histogram will give her information how her data is distributed. Okay, whether where's the peak, or maybe it's skewed to the right, or where the data is concentrated. Or it might be that room housekeeping can be composed of two processes, and she might find some anomalies in the visualization of her data. But number three, definitely the best answer here is histogram. Okay, so I guess with that, I'll stop now the sharing. Oops, and stop the recording.